The first part, which is geometry, is done for laminar problem. The next thing is meshing. Meshing is nothing but the subdivisions of domain into number of smaller non-overlapping subdomains. So meshing is most important in a CFD or maybe in any analysis. It is the most important thing. So the accuracy of your CFD solution will be based on your number of cells in a grid. So to make mesh, it is most important that you should know what actually is meshing. So drag the mesh from component system and place it in the project schematic. So transfer your geometry to the mesh as you see. So the meshing will be done in science modeler in ANSYS. So most likely uh, it is a grid or a mesh of cells or maybe mesh of elements. The accuracy of CFD solution is governed by the number of cells in a grid. But then if you go on increasing the number of cells in a grid, in it cost in terms of necessary computer hardware and calculation time, which are dependent on the fineness of the grid. So ANSYS provides us the automatic mesh, which will mesh the geometry randomly. So to do it, click on generate mesh. As I mentioned, the accuracy of CFD solution is governed by number of cells in a grid. uh, by seeing this mesh, we can't really say our CFD solution is what to say, more accurate. So firstly, to increase your number of elements, you need to know mesh controls, what all mesh controls will have. So the basic mesh control will be sizing. So I want to have the selection of phase. So click on that icon which has a green color on the face, and just click on the face of your geometry, and then click on apply. So the mesh type I want is element size, and I want element size of 10 mm. So I'm clicking on 10 mm. So you can see that, and then just click on generate mesh. So it will mesh with the size of 10 mm. So it takes some time. So because your mesh element size is 10 mm and your overall geometry is around a length of 3 meters, so it takes somewhat time but not that much. So make sure that your units will be in meters, so it would be easier. So basically, to convert it in meters, it is 1 e power minus 0.002 meters. So you can clearly see that there is somewhat fineness in your mesh, but there is some slightly deviation in the straight lines of your mesh, which are not rectangles or squares. So that is basically because of the behavior which is softer for a mesh. So this softer mesh makes the meshing to behave softer, that it will be into some irregular shapes. So irregular shapes doesn't mean like uh, then the mesh quality will be softer. So behavior will be softer. So I don't want that, so I'm keeping it hard. So let us see what will happen. So you can see there is some slight deviation, but not as much as in the previous software one. When you zoom it to very large, then only you can see it. Okay. The next mesh control I want to say is about refinement. Refinement is nothing but it is an optimal mesh which is often non-uniform, which is finer in areas where the large variations occur from point to point, and coarser in regions with relative little change. I just want to see how the refinement in refinement will increase the number of cells in a grid. So increasing your cells in a grid would increase the accuracy, but for here it is not as much as required because we are doing laminar flow, because the solution won't get converged very easily. You will see it on later why it is so like that. So to have a better idea of refinement, I'm just showing it. So after refinement you can see that there will be a increase in elements. So so let us see. So you can see clearly see that there is increase in number of elements with refinement. So even after refinement also we can see there are some deviations in the straight lines, which is more likely behaving like a curves. So to overcome it in mesh control you'll have something like face mapping. So if you keep that, you can clearly see straight lines. So basically this refinement of mesh for the laminar flow in a pipe is not much required. So just to make you guys to have some better idea about refinement, I'm just showing it. Even you can do refinement and then just cross check the results of your this thing. So this is what is basically you do in CFD. You mesh and then just check the results whether they are changing or not. So okay, I just don't want refinement, so I'm deleting it. Having refinement will make my computer to do more computations with more or less same value, and it would take a lot of time. So it is not required. So you guys even check out for phased mapping to have the straight lines. So I'm just deleting this, which is not required, and then just generate mesh. So after generating mesh you can see it is in a normal. So once just cross check the boundary, sorry, named sections, which are more likely we give uh, bo- boundary conditions for them for the named sections. So after closing it, just save your project, and after this we'll see the solver one. So practicing this type of project schematic is must, because for bigger problems it will be more. Thank you guys.